Everyone. Today we want to look at this question. We have seen a lot of shortcuts, but we discovered that we need to know the rudiments. There's need for us to go back to the basics so that we'll be able to solve this question on our own. Those of us that want to write SAT, you must know that by doing past questions, by solving past questions, you understand the pattern and your own, you'll be able to solve the question. Now, left hand side, right hand side. So look at our right hand side. Just listen to this explanation and follow me systematically. Our right hand side is 100. Now, since our 100 is a positive number, that is a number that is greater than 0, it means our 5 raised to power of s is greater than 5 raised to power of y. That is to say, s2 is greater than y. So the first thing you are going to do now is to rewrite, this is the method now, rewrite x as y plus k. I hope you are still following, you are still there. So therefore, your x is equals to y plus k. That's very good. So the next thing you are going to do, substitute for x in the equation. That is the equation here. Anywhere you come across x, plug in your value, y plus k. So let's do the first one. Here, y plus k minus, this is k, minus 5 raised to the power of y equals to 100. So you still remember this initial rule, initial law. So this look exactly like this. So express this in form of this. So here you have 5 raised to the power of y multiplied by 5 raised to the power of k minus 5 raised to the power of y equals to 100. Don't scroll. Still follow us through as we solve it together. Now look at this term. This is a term. This is another term. Now here, 5 raised to the power of y is common to this term, common to this term. So factor it out. This and this is to give you this. If you factor out this one, it's going to give you 1. It's equals to 100. So I want to tell you categorically that this left hand side is okay. You are done with the left hand side. Now your attention should be shifted or should be on the right hand side, this 100. So can you obtain the prime factor of 100, which is this? 50, 25, 5, 5 and 5. That's 1. So you can as well write the prime factors are now this: 2 raised to the power of 2, 5 raised to the power of 2, 4 multiplied by 25. This is simple. Can we continue? Please don't scroll. Now, plug in this to your equation here. So here you have 5 raised to the power of, okay, we're not going to plug it here. We're going to plug it here. 5 raised to the power of y minus 5 raised to the power of k minus 1 equals to 4 multiplied by 25. Not this one, it's this one now. Now, you will now have two equations. Look at it. 5 raised to the power of y equals to 25. Then 5 raised to the power of k minus 1 equals to 4. You will use this and this because here, 5 raised to the power of y, here, if you use this one, it's going to give you, the index form of this is 5 raised to the power of 2. So we can cancel out. We can't use this and this because the base will be different. 5 raised to the power of y, then this one will be 2 raised to the power of 2. Different bases, so they will not go. Okay, so here you have 5 raised to the power of y equals to 5 raised to the power of 2. Equal base, y is equals to 2. So come here, 4 plus 1. So 5 raised to the power of k equals to 5. So your 5 is the same thing as 5 raised to the power of 1. So equal base. So in this case, if you look at it very well, we have obtained our y and we have obtained our k. So we need our x. Don't forget, if you recall from the beginning, from here, we told you that x is equals to y plus k. So we are substituting it for us to get our x. X is equals to 2 plus 1, which is equals to 3. So therefore, x is equals to 3. So from everything here, we can obtain that our x is equals to 3, while our y is equals to 2. So see you in another class. You can do the checking by yourself. Don't forget to like and share our videos. Thank you very much. Your comment is also important to us.